So, welcome back. In our last session, we were discussing about network decisions. We discussed about four important type of decisions which we take. We take decision with respect to role of the facilities. We take decisions with respect to location of the facilities. We take decisions with respect to their sizes, and then we take decisions with respect to market and supply allocations. We discussed about various factors which are responsible for taking decisions for network decisions, and then in our last session we also discussed that how response time and number of facilities are related. We discussed that if we have more number of facilities, the response time will decrease. As we are coming from left to right on the x axis, we are increasing the number of facilities, so our response time is also starts decreasing. So, we already discussed this in our last session. Now, going further, if you see this type of figure, that where you have this particular market which is plant, then here you have distribution centers. These yellow points, these are representing the distribution center, and then all these dots are representing the customers. So, you have these points representing the plant, these yellow points representing the distribution center, and then these marks, small dots, are representing the customer. So, this is a type of situation where you have so many customers, so many distribution centers and few plants. Now, here you see we can say that we require 1 week order response time in this particular case, because you have only 3 plants, 1, 2, 3, 4 plants, and you have very limited number of suppliers with respect to distribution center. So, here I talk, like if I talk of this type of a distribution center or this type of distribution center, here you require at least 1 week response time. So, in this particular case the response time is very high because of limited availability of the distribution centers in this overall global market. Now, let us go to this type of situation. Here you have this distribution center, this distribution center. Now, within this market you have 2 distribution centers, and here in this particular case, because 2 cycles are intersecting, 2 yellow cycles are intersecting. Now, you see here in this particular case, for these people, those customers which are coming in the intersecting cycle, here we have 2 distribution centers. This distribution center can also fulfill the requirement of customers coming in this intersection cycle, and this distribution center can also fulfill the requirement, and as a result of that the response time has reduced from 1 week to 5 days. So, that is the result of 2 distribution centers for the customers which are in the intersecting cycles. Now, you have more such distribution centers, and now you are reducing the cycles of distribution centers, and therefore you will find that in some of the cases you have more than one cycle which are able to fulfill the requirement, because you have 5 distribution center for this market. I am talking of only this market right now. So, for this market, this US market, you have 1, 2, 3, 4, 5 distribution center, and there are at many places customers can be served by more than one distribution center. And what is happening, that we have reduced the response time from 5 days to 3 days. So, as we said that as our facilities, if you go back to this slide. So as our number of facilities are increasing, we have one facility, so at that time 7 days was the response time. We had 2 facilities, 2 distribution center, so response time decreases to 5 days. Now we have 5 distribution center, so response time decreases to 3 days. So that is how we are moving. For more number of distribution centers, less response time. Less response time is we are able to fulfill the requirement of the customer in a faster manner, more with less time. And now you see you have how many? 13 distribution centers. You can see the 13 yellow cycles here, and these 13 yellow circles will further reduce your response time. And here we see that the response time is the next day. You order today, next day you get the supply. So because in many cases here you will see large number of intersecting circles, and as a result of that customers can get benefited by reduced response time. So more circles, more distribution centers, and your response time further decreases. So again strengthening the same thing, that more facilities and response time will decrease. Now going further, you have now how many? You can count these yellow circles. You can count these yellow circles, and the result is already displayed here. That is, these are 26 distribution centers. 26 distribution centers, and your order can be received same day. The same day order, or in some cases like in this case where you do not have any intersecting circle. So probably in these cases, if I talk of this customer, so probably because of the distance from this distribution center to this customer, order may be supplied next day. In this case those 3 customers are very close, but there are 2 customers which are on the periphery of this circle. For them order may be supplied next day. There are few customers which are not part of any of the circles. For these customers order may come after 1 day, all day. So as we are improving our number of facilities, as we are increasing our number of facilities, we can see in this diagram that the response time has further reduced. You are able to get the products in the same day. So from one distribution center, when we are having only one single yellow circle, at that time our response time was 7 days, 1 week, and now we have 26 distribution centers, and the response time is either same day or next day. So as we are increasing the number of facilities, it is very simple to understand that the response time will keep on decreasing. Now you see in this particular case, what are the different types of costs which are associated with facilities. Now as we have this cost versus number of facility graph, so your with facility, as you are increasing the number of facilities, your inventory cost increases, because now if you see you have various distribution centers, 1, 2, 3, 4, one manufacturer, all these are the DCs. Then you have large number of retailers, maybe 1 to 50, and as you are increasing these numbers from 4 to 6, from 50 to 60s, you need at each location, at each facility, some amount of inventory, some amount of products to be kept at each of these locations. So when you are having more facilities in your network, your inventory cost is bound to increase. You have higher inventory cost. So that is one simple lesson, that more facilities, more inventory cost. The second is transportation. The second is transportation. Now in the case of transportation, you see the cost starts decreasing. As we are increasing the number of facilities, the cost starts decreasing to some point here, and then all of a sudden it starts increasing. Why it happens? Why it happens that way, that cost is decreasing to a point and then it starts increasing? The reason is that transportation cost can be divided into two parts. Transportation cost can be divided into two parts. If this is a facility, in a supply chain, so there are some materials which are coming to the facility and there are some materials which are leaving the facility in a supply chain. So materials which are coming to a facility, the cost of transportation, associated with the inbound material is known as inbound transportation cost. This is inbound transportation cost, and the cost associated with the materials leaving the facility, that is known as outbound transportation cost. It is very simple to understand that normally the size of consignment which we receive at a particular facility is larger, is bigger than the size of consignment leaving the facility. The size of consignment leaving the facility is normally smaller than the size of consignment coming to facility. We know that if I am a manufacturer, I receive raw material in large quantities and which is very homogeneous also, and the finished products, because these finished products will go to many dealers, many distribution centers, so the size of outbound transportation, outbound consignment will be smaller. The point which I am trying to say, here you get inbound logistics, here you get sufficient economies of scale, but here that economies of scale will not be there. Here that economies of scale will not be there, though we try to keep some amount of economies of scale even in the outbound transportation also. When we are making more and more facilities, we are trying to go closer to the customer. So what will happen? We may lose after a particular level of facilities, after a particular number of facilities, we may lose all of a sudden economies of scale even in inbound transportation cost, because more facilities, so the size of inbound consignment will also reduce, with the assumption that market is not growing. If market is constant and I am making more and more facilities, so in that case it is quite possible that with increasing number of facilities, my economies of scale, my benefit of economies will not be there even in the inbound transportation. And if that happens because of more number of facilities, so transportation cost starts increasing after a particular number of facilities. Otherwise, as long as I am coming to this side, transportation cost will decrease because I will be going closer to my customer and I will continuously decrease my outbound transportation cost. I am going closer to the customer, so this outbound transportation cost, which is much higher than the inbound transportation cost, this cost is higher than this inbound transportation cost. So making more number of facilities will help me to reduce the outbound transportation cost, as long as I am able to maintain economies of scale in the inbound transportation cost. But what I said, that after a particular number of facilities, I may lose economies of scale in the inbound transportation cost also, and at that time the benefits of reduced outbound transportation cost will be nullified, or rather I need to pay more if that happens, if I lose the economies of scale in my inbound transportation cost, and therefore I can have this type of increase, very sharp increase in the transportation cost of the product after a particular number of facilities. So that is the discussion about the second important cost with respect to number of facilities. The third cost of the facility cost itself. This is the facility cost. So, as I am making more number of facilities, I need to develop the required infrastructure, I need to put my capital into that, and as a result of that, with more number of facilities, I have increasing the cost of facility. Up to some level, you see I am moving in a very linear fashion up to here, but beyond this point, there will be a very sharp increase, exponential increase in the facility cost. I will ask my students to think on this aspect, that why the cost of facility increases in this exponential manner after a particular level, after a particular number of facilities. And probably in our next session I will like to reply, I will give you this question right now, that why you have this straight line up to a particular point of number of facilities, and beyond this the shape of the curve changes and it becomes more exponential in nature with respect to facility cost. And you please think through, and in our next class we will like to discuss the answer of this very question. Then if I combine my various types of cost, so this type of curve emerges where this curve at the top represents the total cost, which is the sum of facilities, inventory, transportation and labor cost. More number of facilities, so with increase in facilities you have a step increase in the labor cost also. You have transportation cost decreasing and then increasing, you have inventory cost which increases with number of facilities and the cost of facilities itself, and as a result of that you have this total cost curve where total cost is decreasing up to a point and then it starts increasing because of increase in the transportation cost. And then the role of services and facilities is also very important. With your increased number of facilities, why are you increasing the number of facilities? The question is, why are you increasing the number of facilities? We increase facilities because we want to serve our customer in a more satisfying manner, or you can say that we want to achieve higher level of services by providing more number of facilities. More number of facilities, going closer to the customer, and going closer to the customer will bring better service level. So, as you are seeing with this curve that your service level is increasing with number of facilities. As you are increasing the number of facilities, your service level is also improving. So, this is a combined discussion of variety of costs and the service level which you get with the increased number of facilities. Now, with this discussion, we can now understand that what should be the ideal number of facilities. Now, if you see the total cost curve, the lowest point of this total cost curve somewhere here around this point, and here if I get this level of service, and if this level of service is within the my promised limits to my customer, then I will like to keep this as the number of facilities, these number of facilities I will like to keep, and you see this is the point of intersection of my facility cost and the transportation cost also. So, this is the point where I get the minimum cost of facilities, and this is the level of service. Now, if I want to improve my service level, if I want to improve my service level, this is only possible when I will incur additional cost of facilities. Additional cost of facilities will be required for improved service level, for higher response rates. And in case of a product where we want very high level of responsiveness, we can go with higher level of service, and accordingly cost of offering that service will also increase. So those products probably of emergency nature where we require very high level of service, in that case cost many a times may not matter, and therefore you will provide higher level of services by going to the higher level of cost by increasing the number of facilities. Like in the case of humanitarian supply chains, the disaster supply chains, where you are providing the facilities for better rehabilitation, for immediate relief of the victims. In those cases cost issues are secondary. The ability to provide relief immediately is more important, and in such type of situations we will like to have more number of facilities in those disaster prone areas, in those risky areas where you feel that disasters may come, and for that purpose to provide higher level of services you keep your ambulances, your nursing homes, your other dispensaries, your other facilities always readily available, and therefore your cost is also high, but in those situations we require very high level of response, and therefore it is well justified. But in many other cases the higher level of response or service may not be required, and therefore it is not essential to increase the cost of your offering by increasing the number of facilities. So therefore in most of the cases it is always advisable to understand this graph very carefully. For the practitioners, those who are attending this class, it is always advisable that please understand this breakup and try to optimize the number of facilities. Otherwise you will increase the number of facility, but you will not have proportionate increase in service level, because you see the service level curve becomes almost stagnant after a particular time, and therefore understanding of this graph is very important. Now moving further, let us quickly see that once we are deciding about the location of the facility, so how do we select the site in a global environment? What are the different phases involved? You see, this is a 4-phase process, phase 1, 2, 3, 4. The process starts with the supply chain strategy. This is the first stage of our site allocation, site selection, that what is my supply chain strategy, because all the facility location decisions must be in line with your supply chain strategy. So understanding the strategy is very important. I discussed in my last class about Walmart and 7-Eleven. The Walmart strategy is to provide low cost products. The 7-Eleven strategy is to provide the very high level of responsiveness. If I am an emergency type of hospital, so my condition is different, and if I am a hospital for routine medicines, so in that case my condition is slightly different. So this depends upon my whether I am a routine type of hospital or I am there to handle the emergency cases. So as per that my first important thing is supply chain strategy. Now supply chain strategy is we have already discussed. Just for a very quick brush up we will like to discuss that it comes from the competitive strategy of the organization. What is the competitive strategy of the organization? That derives your supply chain strategy, and then the other factors which contribute in proper understanding of the supply chain strategy or proper you can say written framework of the supply chain strategy. One is the internal constraints and the second is the global competition. These are the two more factors which are very important in deciding the supply chain strategy. So totally there are three inputs for my supply chain strategy. One is the competitive strategy of the organization. Second is the global competition, what is going on at the global level with respect to your industry. And the third is the internal constraints, that constraints related to capital, the growth strategy, the existing network, etc. These things also play important role, because if I am, let's say, Tata Motors, and I am launching Tata Nano, a new vehicle in my portfolio. So I cannot have entirely new network of distribution for Tata Nano, because I already have a distribution network for my other products, and I will like to have some kind of synergy with my existing network. On the other hand, we have the example of recent example of Maruti Nexa, where Maruti, to promote its exclusive type of products, is not using the existing network, and Maruti has created a separate network of distributorship named as Nexa. So it depends upon what type of growth strategy, what type of existing network. In case of Maruti, though we all know Maruti is known for its largest network among the automobiles, but still for its exclusive products, if they want to have some kind of different positioning of some of their products, they go for the Maruti Nexa. So it depends that what type of growth strategy, what type of capital requirement you have, and then on the basis of that you decide your supply chain strategy. The second phase is the regional facility configuration. Now on the basis of that you have certain regional considerations, and regional considerations come from the tariffs and tax incentives. Like when new states of Uttarakhand, Chhattisgarh and Jharkhand came into existence in India, Uttarakhand government, so on Chhattisgarh, so on Jharkhand, gave lot of tax incentives to new organizations, and as a result of that many new companies, many new MNCs, they opened their facilities in these new states. So some type of tax incentives, what type of tax incentives are available in a regional area, what is the regional demand, whether we have any regional demand or not. Most of these states were not having any kind of regional demand, but because of very heavy tax incentives, many facilities came in these areas. Then certain political stability type of issues are also very important, and because industry can only survive, facilities can only survive where you have political stability. Then another issues are related to production technologies, whether we have appropriate technologies available. This issue is more important when I look at the global level. So because in that case the regional issue is a particular country. If I talk in case of India, so regional issue is related to a particular state. So in that case, what type of technology support will be available in country like India or any other country where I am thinking to establish my facility, and what is the competitive environment? Do we have a positive competitive environment in that regional area or not? So that is also very important, and with these things I draw some conclusion about my regional configuration. I divide the global market, global arena in certain regions, and then I do this type of analysis for all those regions, and on the basis of that I may consider one or more than one regions which are favorable for my decision making. And once I have done that, the third issue is related to sites. Within that region, what are the possible sites where I can locate my facility? Like if I take a regional issue related to Uttarakhand, if Uttarakhand is one region, so desirable sites can be Udham Singh Nagar, desirable sites can be Sitarganj, desirable sites can be Haridwar, and out of that I will look that what is the available infrastructure in each of these sites. Now I will go to a very specific issue related to power availability, related to manpower availability, related to railroad infrastructure, related to water availability, etc. And the production methods, skill needs and response times. Means what type of skills are available in that particular site and what will be the response time, how I will manage the response time from this particular site. So, depending upon my market and supply allocations, I will take the decisions with respect to response time. And on the basis of this, finally, I will like to decide, I will come to a particular location where I will see the issues related to logistics cost, issues related to factor cost of labor, material and some site specific issues. So, when these 4 stages are passed, I can take decision with respect to location of a particular facility in a particular region at a particular site. We will see, we are stopping our this session at this end, but in our next session we will see that some of the mathematical models, some of the mathematical analysis which can help us in selecting the regional facility and the desirable sites on the basis of various inputs which we are required, and some mathematical models are there, and we will request you that if you can practice some Excel solver kind of thing, if you can install Excel solver in your computers, and we will do some questions here, and with the help of those questions you can also practice at your end, and then you can see that how in real time the modeling related to networks can be done, because the decisions related to stage 1 of the supply chain, where we are talking of manufacturing related decisions, these are a permanent type of decisions, but decisions related to next stages, retailers, distribution centers are more dynamic into nature, and where we require more real time analysis. So, thank you very much. We stop at this time, and we will look for your participation with Excel solver in our next session. Thank you very much.